Hi, this is Kevin, and in this video I'm going to explain and demonstrate the project that me and Elly did for EGR484. Our project is a smart door monitoring and entrance control system based upon a Raspberry Pi and the Raspberry Pi camera module. Our code is based on a tutorial from a man named Adrian Rosbach from the piimagesearch.com website. He also put up a second very helpful article on how to install OpenCV, which is the library that is required to do facial detection on the Raspberry Pi. Our program uses Schaaf deep learning software to do facial detection, and then it will notify personnel inside a building when somebody approaches a door and a face is detected. That person will then be able to remotely control the lock on the door to let that person in. We added some extra features to make this even more useful using SSH and VNC servers. We have made it so our Raspberry Pi based system can be controlled by any computer on the same network as the Raspberry Pi, so you wouldn't have to even be near the Pi terminal or by the door. Anybody in the building you want to have access to it could see who was there and buzz somebody in from their own workstation. Because this is going to be done from a remote terminal, I'm going to record this video using my computer so you can see my desktop right now. I also have set up a webcam that shows our system. If you look down here, you see our hardware. We have the Raspberry Pi camera module. Over here we have the Raspberry Pi. And then we have a breadboard circuit. We have here the solenoid that controls the door lock. This red light indicates a locked door. There is a green light that is currently not illuminated that indicates an open door. Behind these two wires is a buzzer that will notify personnel when somebody wants to come in. And back behind here is a small relay module that controls the power to this solenoid. The power comes from a separate 5-volt supply, and when this relay is given a ground by the Raspberry Pi, it lets that power go through and close the solenoid. And then if we scroll up, you can see the Raspberry Pi is currently turned on and running. And our webcam seems to have frozen. There we go. Now we have the control back. It was just a little bit of lag. Now I'm going to show you how to remote access the Raspberry Pi from your terminal. The first program we use is called PuTTY SSH. There are multiple programs that can do this. Anything that can connect via SSH, which just stands for Secure Shell. So I type in the name of the Pi on the network. You could also type in the IP address if you have not named your Pi. And click open. You get a login here. You put your username and the password, and this is that password that the Pi always gives you pop-up menus telling you to change the first time, so people can't access your Pi like I am doing now. And now as you see, we have a Pi terminal, and I'm going to type in the following command. It's just VNC server, and that's going to turn on a server within the Pi that I can access through this program called Tight VNC Viewer. I've also installed a program called Tight VNC Server on the Pi to make the two compatible. As you see down here, here is the name of the server, and then I've got that server name up here. I hit connect, type in another password, and now you see we have the Raspberry Pi's desktop up on our screen. So on the Pi's desktop here, what we have is a couple little bash scripts that I created, and what those scripts do is they make little they basically automate the process of typing in the commands to run our program in the terminal. And by doing that, We can start our program with one click, but I'll show you how these scripts work. The second one's just one line, so I'm going to focus on the top one up here. The second one just says kill all the Python codes. It just says sudo kill all Python. But here you see the first line just identifies the program as a bash script, so the computer knows what to do when it runs it. This next line loads up our default user profile, and that's important because I've saved a virtual workspace I've named CV in our file, and the settings to get to that are saved in this profile. And then this work on command opens up that virtual workspace, and that lets us access the CV library. The reason for this workspace is it's much less resource intensive to have the virtual workspace and only have the CV library running when that workspace is active. Otherwise, it takes a lot of the Pi's resources up. Then these next three lines just change directories one by one until we get from the desktop directory into the directory with our code. And this last line is the line to run our code. Python tells it the operating language. Detect faces video pi is our file. This postscript here tells the program where to find the calf models so it can get the models for the facial recognition, and they're just saved in a text file in that directory. And this last subscript tells it the resolution and size of those models so it knows how to work with them once it finds them. So what I'm going to do now is go ahead and close that out, and I'll start the program. The program takes about 10 seconds to start running just because it's got to load that workspace, so we'll give it just a second while it fires up. And here we see our program. And now this is the view from the Pi camera. And because I'm by myself, we're going to get a little bit creative here to have a visitor approach that our camera can see. So here we go. Listen closely. Once it detects a visitor's approach and it sees a face, you'll hear a buzzer. Our buzzer's kind of quiet, but it sounds like something you'd hear in a hospital. So keep your eyes or ears peeled for that. Here is our lovely model coming up to the door. And as we can see, it detected the face. These little numbers up top just show about how much of the percentage it recognizes it as a face. It's kind of hard to read with the screen at the size it is, but I'll see if I make it a little bigger. Yeah, it's really hard to read on the screen capture, but I believe it's saying it's in the mid to high 50s, and our threshold is 50% right now. We could up that a bit if we wanted to. But now that it's detecting that's beeping, all I have to do is press the O button, and what that will do is that will cause the solenoid here to retract and unlock the door. This light will also change to green. The door will stay unlocked for 3 seconds to give our guest time to come in. So I'm going to go ahead and do that now. Let me make it so you can see the hardware down there. Pressing O. And there you see it went. We have 3 seconds. And now it came back. I'm going to press it again, and this time I'm going to take our guest out of the camera's picture. And you see the system is working again and there's no beeping. And now just to demonstrate that the facial recognition software or the facial detection software works with a real person, I'm going to go over and get myself in the frame. Unfortunately, I can't reach to the keyboard to let myself in, but we've demonstrated that part works already. And as you can hear hear the beeping now. You can see it's recognizing my face, and you should be able to see me in the camera. And that is our project. Thank you very much for taking the time to watch this video.